In this video, we are going to solve the Leetcode problem of the day, and the problem is count equal and divisible pairs in an array. The question is marked as easy, and honestly the solution is easy if you are talking about brute force, and it is also accepting the brute force solution because the constraints given are too small. But if you talk about the actual optimized solution, it requires a bit of mathematics as well. So we will see both the approach, the brute force and the optimized approach. And I can guarantee you that after watching this video, you will have no problem solving this question in the most optimized way possible. Okay. So let us talk about what is the input in this particular problem. So we are given an array of integers of size n, that is the length of your array is n. You are also given an integer k, and what you need to give in the output is you need to find out the number of equal pairs you have in your array whose indexes product is divisible by k. Now this might sound a bit complex to understand if you are trying to understand the problem itself, but it is very simple. See, you just need to find all the equal pairs, and you need to make sure that the indexes of those equal pairs, when you take a product of it, it gets divisible by k. So this is one of the example input we have, and in this is our array, and we have a k which is equal to 2. The number of elements in my array are 1, 2, 3, 4, 5, 6 and 7. So we have 7 elements in our array, and the output in this scenario is 4. It means that we have 4 equal pairs in our array, and those equal pairs have their indexes at such a place that the product of those indexes is divisible by k. Let us take an example. I can form a pair 3, 3 from this array. How? I can take this 3 and this 3. I can form a pair out of it. Okay. Now why I can say this is an equal pair? That's because it has 2 elements and both the elements are same. One more very important thing to understand here is you cannot say that this 3, 3 is a pair and this 3 is coming from this particular 3 and this 3 is also coming from this 3. That is, you cannot take the same number and create a pair out of it. The indexes of your pairs should be different as well, right? So I can take this 3 and this 3 because they are at different indexes. I cannot take the same 3 and take it 2 times to form a pair. Now I can take this and this, form a pair, and now according to the output, I need equal pairs, right? I got an equal pair. Now there is another condition that the indexes of those equal pairs, when you take the product of it, it is divisible by k. So what are the indexes of 3 and 3? It is 0 and 6. Okay, we have 7 elements. This is at index number 0. This is at index number 6. So the indexes of my pair is 0, 6. What is the product of my indexes? 0 multiplied by 6 is equal to 0. So this is the product, and is it divisible by k? The value of k is 2. So 0 mod 2, the output is 0. So whenever you take a mod of a number from another number and the output is 0, in that case you can say that this number is divisible by the other number. So 0 mod 2 is equal to 2. So 0 is fine, right? So from here I can say that this particular pair is fine and I will count it. It's a valid pair. The question says that we need to count all the equal and divisible pairs, right? So out of this particular example, I have got 4 equal and divisible pairs. We saw the example of 3, 3. It's very important to understand the other 3 pairs as well. Now I can create a pair 2, 2. How? I can take this 2 and this 2. These two can form a pair, right? Apart from this, I can take this and this as well and create another pair out of it. Or I can say this and this 2 and I can create another pair out of it. Every time I am taking unique indexes, okay? For example, this particular pair 2, 2. The indexes are 2 and 3. 0, 1, 2, 3, 4, 5, 6. So the indexes are 2 and 3, right? 2, 3. What is the product? The product is 6. And is this 6 divisible by my k? The k is 2. So 6 mod 2 is equal to 0. From here I can say that this pair is also valid, which is at index number 2 and index number 3. Now I can take 2 more numbers and form a pair 2, 2, which is at index number 3 and index number 4. So the elements at 3 and 4 are 2 and 2. So you can form a pair, and the product of 3 and 4 is 12. 12 is also divisible by 2. So this is also a valid pair. The other one is 2, 2, which is at index number 2 and index number 4. Now you will notice that every time I am taking unique indexes, right? I am not repeating any index pair, and neither I am repeating the indexes as well, right? So I cannot say 2, 4 again because I have already counted it, and I cannot say 2, 2 as an index because I cannot take the same number twice. So this 2, 4 is 2, 2, right? This is also forming a pair, and 2 multiplied by 4 is equal to 8. That is the product. 8 mod 2 is equal to 0, and that is this product is divisible by k. So this is also a valid pair. So I have got total 1, 2, 3 and 4 valid pairs, and that's the output of this particular example. Now let us take the example of one invalid pair. You can say that this 1 and 1 is also forming a pair, and that's correct. You can say this is also a pair. This is a pair, but is this valid or not? Because we have some other condition that the indexes product should be divisible by k. So what is the index of 1, 1? It's 1, 5 because we have this 0, 1, 2, 3, 4 and then 5. So index 1 and index 5. So we have this 1, 5 whose product is 5. 5 mod 2 is equal to 1. That's not equal to 0, right? And that is why this is invalid. We can say this pair is invalid and we are not going to count it. Now this is the complete understanding of this problem itself. The first way to solve this problem, which is actually going to pass all your test cases, is brute force. That is, what we need in this problem is pairs, right? We need pairs those are equal. So let us try to create all the pairs which are possible. So if there are 7 numbers, I can create 7 multiplied by 6, 42 different pairs. I will create all those 42 pairs and we can try to see two things. First, that the numbers should be equal. Since we are creating all the pairs, we might create a pair 3, 1 as well, right? 3, 2 as well, right? So we need to process all those pairs whose numbers are equal, and then once they are equal, we need to check that the indexes product is also divisible by k. The formula or the algorithm is very simple. You can run two loops. Why two loops? Because we need to create the pairs. And since we are running two loops, the time complexity is going to be O of n square. The second loop is going to be inside the first loop, right? And that is why the time complexity is O n square. We are not going to use any extra space, and space complexity is going to be O of 1. Let us say that the I and j are the looping indexes. That is, the first loop running is I, the second loop running is j. So every time we need to check that the numbers at index I and index j are same. Once the numbers are same, we need to check another condition, that I multiplied by j, that's the product. You take the mod of it with k, and if it is equal to 0, you can count it. And that's it. This is the simple algorithm to solve this particular problem. And let me actually show you the solution. So this is the solution, which you can say it is the brute force solution for this problem, where you are creating a variable count or c, which is initially 0. Then let us run the first loop, which will run for each of the numbers, and there is another loop for j, which is going to run from I plus 1 to the end of my array. Now for every pair, I need to check a condition that if the numbers of I and j are equal, that is, the numbers should be equal, then we are going to check another condition, that the index I multiplied by index j when taken a mod with k is equal to 0. And if the condition is true, we can say count plus 1 or c plus 1. And then we can come out of the loop and we can say return the value of c. And this is actually an accepted solution. And if you will submit this code, it is going to pass all your test cases. Now let me come back to the drawing pad and let me try to explain you the actual optimized solution for this particular problem. I would say it is a bit hard to understand, but just at the point till you don't know the math. Once I tell you the maths behind this, it is going to be really easy to understand. Okay. So let me try to solve it again. This is my array. This is my input, right? 3, 1, 2, 2, 2, 1, 3. These are my indexes and this is the value of k. Now let us try to break everything step by step. First of all, I need equal pairs, right? I just need equal pairs, and then only I can check the indexes. I don't want to check those indexes whose numbers are not same. What I mean by this is the indexes are 0, 1, 2, dot, 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 up to 6, right? Now I don't want to say index 1 and index 2, take the product of it, 1 multiplied by 2, and then take the mod of it with k. I don't want to do it, and that is because the numbers at index 1 and index 2 are different, right? It is 1 and it is 2. So I care about those pairs whose numbers are same, not different, right? So I care about a pair whose numbers are same, something like 2, 2. So now the indexes 2 and 3 does matter to me, okay? So I can say 2 into 3 mod 2, that is k, and this time I'm going to get 0. So I would say this is a valid pair. I want to eliminate one very important task. I want to create a mapping where I want to store all the indexes whose numbers are same. For example, the index 2, 3 and 4, they have the same number, that is 2. The index 0 and 6 have the same number, that is 3. And the index 1 and 5 has the same number, that is 1. So I am creating a mapping that the number 3 belongs to the index 0, 6, the number 1 belongs to the index 1, 5, and the number 2 belongs to the indexes 2, 3, 4. This is my index mapping. Now why this is very useful and why I should think about it. Now that I have this information, now I have grouped my indexes. If I select any particular group and try to create a pair out of it. So let's say this is my group and I say, okay, 2, 4. I'm just taking it randomly. So the 2 and the 4, these are indexes. So this time I am sure that the value at index 2 and the value at index 4, they are same. So this is saying that the index value 2, the index value 4 is 2 and 2. That is same. So now I don't need to worry about the numbers actually being equal because I have grouped their indexes. So every time I am creating a pair out of the same group, I am sure that the number is going to be same, right? Any pair out of this group will have the number as 3. So I don't need to worry about the condition that I have to form equal pairs because now I have grouped them. I will only be forming equal pairs. Now the next thing is, what do we need? We actually need two indexes, I and j, out of our grouped indexes. Okay, any index I and j whose product is divisible by k is fine for us. For example, 2, 3 is fine, 3, 4 is fine, 2, 4 is fine, 0, 6 is fine, but 1, 5 is not fine. So we have total 4 as an output for this particular input. We have already seen how we can get the output, but let us focus on the optimized version. We are going to apply a very important property of mathematics. Let's say I have a number 102. Okay. Now tell me one very simple question, that if this is your number 102, is this number divisible by 6? So you would say yes, 102 mod 6, this is equal to 0. So I know that this 102 can be divisible by 6. But there is another way to find the same thing, that is this 102 divisible by 6. What you can do is, you can take the factors of 6. 6 factors are 2 and 3. The factors of 102 are 2, 3 and 17. Okay. Now I can say that 102 is divisible by 6 if all the factors of 6 are present in 102. The factors of 6 are 2 and 3. So 2 and 3 are present in this particular number 102. And then I can say that 102 can be divided by 6. I don't care about 17. I just care about 2 and 3, which is there in my dividing number. So 2 and 3 are the factors of 6. They are also present in 102. So yes, the answer is yes. Now let's imagine that this 102 is actually equal to your I multiplied by j. Okay, so let's say you have two indexes I and j. The numbers at these indexes are common, that is equal. And now if you take a product of these indexes I multiplied by j, this is 102. Let's imagine that. Okay, and let's say that the value of k is equal to 6. Okay, we are going to apply the same mathematics here. What we are going to do is, let's say that the value of I is 34, which is actually 2 into 17. From 2, 3 and 17, I am saying that 2 into 17 is I, and the other 3 is j. Okay, so I into j is equal to 102, and we have this k which is equal to 6, and I can say it is actually equal to 2 and 3, 2 multiplied by 3. Now from here I can say that I got this 2 from I and I got this 3 from j. So if you are going to multiply I with j, then I am sure that it is divisible by k. It's very important to understand here is, now let us say that you don't know about j, you just know about I. Your I is 34, your k is 6. Now tell me, I multiplied by j, is this divisible by k? It depends upon the value of j, right? Now what are the possible values of j which is actually going to satisfy this particular condition? The possible values could be 3, or you can say 6 or 9 or 30. These are possible values. What you can do is, you can multiply the number 34 with 3 or 6 or 9 or 30. Whatever is the product you are getting, you will find that it is divisible by k. And how we can say this? Just the simple mathematics which we just explored. See, you have a number I, you have a number k. Now you can say I is equal to 2 multiplied by 17. You can say this k is equal to 2 multiplied by 3. Basic mathematics says that if the factors of your dividing numbers are also present in this number, then this particular number is going to be divisible by k. The factors are 2 and 3. I have a 2. What I need is a number whose factors are 3, right? What are those numbers? Those are 3, 6, 9, 30. Numbers which are divisible by 3 will definitely have 3 as its factor, okay? So let me take some random number out of this, okay? So let us say I take this number 9, okay? So I can say 2 multiplied by 17 multiplied by 9. Now I can say this 9 is actually equal to 3 multiplied by 3, right? So from here I can say that k is having factors as 2 and 3, right? I got this 2 from this 2, I got this 3 from this 3. So if the indexes are 34 and 9, then the product of 34 multiplied by 9 is actually going to be divisible by 6, and that 6 is our k here, just as an example I am telling you. So from here I can say that the numbers at the index 34 and 9 are equal, and we are going to count it. So we are going to count the pair which is forming from the index 34, 9, and we are going to utilize this fact that all the factors of k should be there in I multiplied by j. See, the algorithm to find this value is very simple. You need to find the GCD, the greatest common divisor of your number I and your number k. So let me create some space here, and let us say that we have two values, okay? We have two values which is I equal to 34 and k equal to 6. I need to find a value j, right? 34 I can say it is equal to 2 multiplied by 17, and 6 I can say it is equal to 2 multiplied by 3. What is the possible value of j? We found a value which is 9, right? Or 3 is also possible. How can we get it? See, what we can do is, we can try to find the GCD, the greatest common divisor of I and k. I is equal to 34, k is equal to 6. The greatest common divisor is going to be equal to 2, okay? Now I have this 2. This 2 is telling me that this 2 factor is present in k as well as in I. So let me actually get rid of this factor from my k. K divided by GCD. My current k is 6, GCD is 2, so this value is going to be equal to 3. Now this particular value is actually telling me that what is the number, or what is the factor I need. It needs a factor of 3, because 6 divided by 2 is equal to 3, right? This is 6, this is 2. So now I need this number 3, right? I need any number whose factors are 3. So this is the formula we are going to apply. We are going to say I have a value of I have a value of k. Now let me know what is the value, or what is the possible value of j. So I have this value of k. I will find the GCD of I and k, and then I will divide my k with this GCD, that is the greatest common divisor, and this particular value is going to tell me what is the factor I should have in my value j. So now again let us focus on our original example. We had 3 values in our example, 3, 1 and 2. The indexes for 3 are 0 and 6. For 1 it is 1 and 5. For 2 it is 2, 3 and 4, and the value of k is equal to 2. First thing which you need to find is what are the factors of my k. So the factors of my k are 2 and 1, okay? Because this k can be divisible by 2 and 1, okay? So this you can say as the divisors or the factors. Now let us focus on a particular group of indexes, 2, 3, 4. So we have an index 2, we have an index 3, we have an index 4. How many pairs can I form using these indexes? I don't need to worry about the value, right? Because the value is going to be same. Any pair I create out of this indexes, the value is going to be 2. What I need to worry about is, can I form a valid pair from this index, or from this index, or from 2, 4? That's the question, right? So what I will do is, I will ask each index, how many pair can you form? So let me ask this question from this particular index 2. Now this 2 is going to be equal to our I, okay? So we have a I which is equal to 2. We have a k which is equal to 2, right? Then what is the GCD? Coming back to the formula, right? We have a I equal to 2, we have a k equal to 2. What is the GCD? The greatest common divisor of 2, 2 is 2 itself, okay? So let me put it in this formula and say that the value of k is 2, the value of GCD is 2, so this is equal to 1, right? So the number which I need to form a pair with this index 2 should have a divisor or should have a factor which is 1. Now the thing is, I'm actually going to create a mapping. Okay, this mapping will store two values. The key is going to be the factors of my number k, and the count, I will find out how many numbers have I seen which has 1 as a factor or which has 2 as a factor, because we just need those numbers which has 1 and 2 as factors, right? So the moment I see a 2, I got a number that is I, which is having a factor of 2, right? And now from this formula we have got that the value of j should have a factor of 1, right? Now have I seen a value when I'm talking about 2? Have I seen any value previously which is having the factor as 1? No, I have not. So right now this is actually empty. Okay, for 1 it is 0, for 2 it is 0. We don't have any number whose factors are 1 or 2. We have not seen any number when I'm talking about 2. Okay, so for 2 the output is going to be 0, that is I have not got any pair with this particular 2. But now we are actually going to store a very important information. When we will process this index 3, this 3 should know about what is the information the 2 is having, and that is because when we were at 2 we were asking how many numbers have I seen previously who are having the factors of 1 and 2. So we don't have any number, but when we are going to ask the same question from 3, we are going to have a number 2. So I am going to store a very important information that from 1 and 2, what are the different numbers which can divide my number 2. So 2 can be divided by 1 and 2 can be divided by 2 as well. That is, 2 has a factor of 1 and 2 both. So this time I am going to increase my count. Okay, so this is going to be 1 and this is going to be 1. So 1 and 1. Right now don't worry about this. Just focus on the fact that the value of 1 and 2 are 1 and 1, the count. Now let us ask the same question with 3, and before asking, the number of pairs we got with 2 is equal to 0 for now. So when we are at 3, our I is actually equal to 3, k is 2, right? What is the GCD? The GCD or the greatest common divisor is 1. For 3, 2 it is 1. So let me put it in this particular formula. K divided by 1. K is 2. 2 divided by 1. This is equal to 2, right? This is telling me that the other index which you need, that is the j, should have a factor which is equal to 2. So I am going to ask the question at 3 that have I seen a number previously who has a factor 2? So let me check it from my map. For 2 the value is 1. For the 1 the value is 1. So for 2 I have seen one number till now, till this point, such that that number is having a factor as 2. So at 3 I needed a number j which has a factor 2, right? I got one such number. So at 3 I can say that I have got one pair whose values are equal and whose indexes when producted or multiplied will be divisible by k. Now we are going to do the same processing with 4, and before we proceed, let me check what are the factors which can divide 3. So 1 can divide 3 but 2 cannot divide 3, right? So I will say after processing this information, these two indexes, my count will look something like 1 plus 1 in case of 1, because both of these numbers can be divided by 1. But for 2, only this 2 is having 2 as its factor, right? 3 doesn't have a factor of 2. So after processing this, the value of 1 is going to be 2, that is 1 plus 1, and the value of 2 is going to be 1, that is 1. So now when we are at this particular index whose value is 4, so this time I is equal to 4, k is equal to 2, the GCD is going to be equal to 2. Now put this into this formula, k is 2, GCD is 2, this is equal to 1. So I need that number who has a factor as 1 in it. So before 5, how many elements or how many numbers have I seen who has 1 as its factor? It's this one we need to check, right? So the value is 1 plus 1, which is 2, right? So at this point, I have seen two numbers, 2 and 3, whose factors are 1. So at 4, I can say the output is 2. So after we have processed this particular group, the output is going to be 0 plus 1 plus 2, which is 3. So we can form total 3 pairs out of it. And that is what we are forming, 2, 3, 3, 4, and 2, 4, right? 3 pairs. And now I think you can process the same information for other groups as well. You can get the count and then return the total count. For example, let us process this 1, 5. It will be, so for 1, the output is going to be 0, and for 5, it is 0. How? So when I is 1 and k is 2, the GCD is going to be 1. And when you put this into the formula, 2 divided by GCD, that is 1. So this is equal to 2. So I need a j who has a factor of 2. So I can say, okay, have I seen a number before this 1 which has a factor of 2? No, I have not, right? So in this case, the output is going to be 0. But when we proceed further to process this number 5, we can say that when we are processing 5, the count of 1 is going to be 1 and count of 2 is going to be 0. That's because I have seen a number 1 which is having a factor of 1. I don't have any number which I have seen which has a factor of 2. So again, when you will process 5, you will get the output as 0. And when you start processing for 0 and 6, this particular group, you will find that at 0, you don't have any pair. But at 6, you will see that the value of I is 6, the value of k is 2, the GCD is 2, greatest common divisor is 2. You put it into this formula, you can say 2 divided by 2, this is equal to 1. I need an index who has a factor of 1. I have already seen that number, which is 0. 0 actually has factor of all the numbers, right? So you can say 0 has a factor of 1. So you can count it and you can say, okay. So for 6, you have seen a number who has a factor of 1. How many numbers have you seen? Just 1. This 0, right? So I can say for 6, the output is going to be 1. I have seen 3 pairs. I got one more pair. 3 plus 1 is going to be equal to 4, right? And that is my final output. And that is the complete explanation of this particular approach. So let me show you how the solution will actually look like. So the solution will look something like this. Here what we have is we have a count variable where we are going to store our count. That is the number of pairs which we need to return. Then the factors and the indexes. First of all, we are going to update our factors. That is, we are going to run a loop from 1 to k plus 1. and for every value I need to check if that value can divide by number k, and if yes, that is a factor. Then factors of k is going to be stored, and okay, I have printed it, you don't need to print it. Next is you need to run a loop. You need to enumerate your numbers, that is your arrays, and then you will need to group your indexes. So for that I can say indexes, this is a default dictionary, that is a map, and every value is going to be a list, right? So for every number or for every unique number, I'm going to create a list and I'm going to append its indexes, right? So this is the loop for that. And then what I'm going to do is for every indexes or for every group of indexes, I'm going to run a loop that is going to be assigned in the index variable. Then I'm going to create a new data dictionary, which is actually going to be having all the factors initialized as 0. It means that I have not seen any element with a particular factor. So initially it is going to be 0. Then again, you don't need to print anything. Now in each index group, I'm going to run a loop and I'm going to check for each index. That is, first of all, I'm going to find out my j. That is the value of the factor which I need. I'm going to put it in the formula k divided by the GCD of k and I. This value is going to tell me that what factor should my other index have. And once I calculate it, I just need to increase my count by the number of items I have already seen, or by the number of indexes I have already seen who has a factor of j. So count is equal to count plus data of j. This is our data, right? And after performing this addition, I need to run a loop for each element of my factors, and I need to increase the count in case my current number or my current index can be divided by my factor. So after you complete this loop, you will have all the values or all the pairs count in the count variable, and you can just return the value of count. And this is the complete solution for this particular problem. You can also find the solution link in the description as well. And if you will notice on the runtime and the memory used, the memory, I would say we have used a lot of memory, but we have definitely improved the runtime, right? And the time complexity, I would say it is roughly equal to O of n multiplied by k. So that's it for this video, guys. I hope this video explains you the problem and the brute force solution as well as the optimized solution as well. And if it did, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to my channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.